Hello, and welcome to our webinar, Common Databricks Mistakes and Real Customer Solutions. I'm Susie, Head of Marketing here at Blueprint. If you're unfamiliar with us, we are a data intelligence firm specializing in data engineering, AI, data governance, and cloud cost management. We've been a trusted Databricks partner since 2016, and we are the 2024 Databricks Data and AI Governance Partner of the Year. Today, I'm excited to introduce our guests, Nick and Christian. Welcome, guys.
Hey, Susie.
Hello, Susie.
Nick and Christian are solution architects at Blueprint. Both are usually deep in client work, so somehow we got them to both show up today. And in addition, both are recognized Databricks champions. So we're in for a wealth of knowledge today. Before we get started, just a quick housekeeping note. You can submit questions throughout the event, regardless of the platform that you've joined. And as I mentioned, given that we have this time with them today, ask away. We'll most likely save the questions for the end, unless immediate clarification is needed during the event. All right. Gentlemen, I'm going to hand it off to you.
Thanks. Today, we're going to talk about the common mistakes in Databricks implementations. And these are the sort of top hitters that Kristen and I see when we're working with clients. Most of them are the upfront, easy to avoid things, but hopefully you can learn some information and take it away. Just for introductions, Christian Foster is our engineering manager. He's been in and around technology for about 17 years with a variety of tools, mostly around the data space. He currently manages our data teams for client implementations. And so he helps keep everyone organized and on task. And also, if there's a deep technical issue, he's very gifted there and will step in and help in those engagements as well. He's worked in multiple industries, as you can see some of those listed here. And so he has a huge wealth of knowledge for each sector. His favorite thing about Databricks is its ability to use different languages across the different departments, all within the same platform. So each group can use the language that suits them best, and that's a great advantage in Databricks. I'm Nicholas Carpenter. I'm a solutions architect. I've been in and around technology for about 22 years. I typically work with a full range of staff, from executives to developers, to design, implement analytical strategies and solutions with our clients. I've worked with most industries one way or another, and typically specialize in data quality, governance, master data, analytics, and ETL automation. My favorite thing about Databricks is really its flexibility to buy versus optimize for performance. So you can figure out what the best ROI for your money is going to be, whether it's refactor code or just basically buy more power and then move on to new projects. We have a quick attendee quiz, so put your answers in the chat and we'll keep up with those. And whether the number is 1, 2, 3, 4, 5 that associates with the answer you want.
All right, our first question for today is, what is your favorite Unity catalog feature? 1, is the ability to use catalogs across multiple workspaces. 2 is dynamic views. 3 is using external locations to store credentials. 4, using foreign catalogs. 5, I have never used Unity catalog.
So if you get a chance, you can go to the chat and put your answer there. I see some answers coming in. So it looks like the most prominent answer right now is number 1, the ability to use catalogs across multiple workspaces. And that's a great answer. The second question is, what is your favorite developer library? 1 is Pandas, 2 is JSON, 3 PySQL, 4 Request, 5 is your own custom library, or number 6 is other. So it looks like it's a tie between 2 JSON and 1 Pandas.
All right. The next question we have is, what theme do you prefer, light or dark or other?
Some answers coming in. There we go. It looks like either dark or other.
All right.
What IDE do you use the most with Databricks? Visual Studio Code, the natural Databricks web GUI, PyCharm, or for other? So let's see, 1, 2, 3, or 4. Which one's the most prevalent? It's looking like it's a tie maybe between Visual Studio Code and the Databricks web GUI.
All right. We'll go on to the last question, which is, what language do you use most often when you're working with Databricks? Is it Databricks SQL, Python, Scala, mixed, or other?
Where'd that come? It's looking like Databricks, SQL, and Python so far. We'll give it another few seconds. Yeah, it looks like a pretty close tie between Databricks, SQL, and Python. So that's great. So moving on to the main topic. Today we're going to talk about some of the common oversights, and there's 3 general categories that we see. So the first one is overlooking the need to evaluate cloud readiness prior to an implementation. So this includes network planning, firewalls, and then external regulations. The second one is understanding cloud charges, and that's including how billing fully works in a cloud environment, not accounting for chargeback or billing distribution, effective cost monitoring, and then even poor monitoring habits. And then lastly, common patterns to avoid typically for the data engineering team and in your strategy. So this is not taking advantage of distributed processing with your code, not using DevOps, and then choosing the wrong clusters. For the first section, cloud readiness evaluation, frequently clients tend to fail understanding the impact of cloud analytics and data processing, and this leads a lot of times to roadblocks, pains, and barriers for success. When you get into that space, it's not typical for most data engineering teams, but not understanding network paths and how egress can occur and how that affects both performance and expenses. Those costs typically hit a secondary team like an infrastructure or a cloud team that's kind of becoming more prominent in organizations. And that can create some internal geopolitical unrest that can interfere with your project. Firewall rules and firewalls themselves are necessary to protect our information, but it can also generate cost or barriers with connectivity between cloud and on-prem, and then even within our cloud environment. So if you have too many rules, that can be very prohibitive to the data activities. If you have too few rules, that leaves you invulnerable, or like there's some access restriction that you may not have. The external regulations need to be accounted for as well, typically up front, and that helps us avoid reputational damage. It helps us adhere to regulatory compliance, and it needs to be considered ahead of time so that we can really account for it up front. It's not a huge undertaking typically to do that at the very beginning, but once you're knee deep into a project, if you go through and then have to back up and start doing those things, that can be a pretty significant lift. And so avoiding that's a great thing to do. So as far as locations, here we have an Azure data center map. AWS and GCP also have their own data centers throughout the country. In this case, we just chose Azure because we found this nice map that we could show you. But you can see they're distributed all over the nation. And it's very, very common for clients not to be, even they may be aware of it, to not take this into account when they're setting up their Databricks instances and then their sort of cloud platforms. It's typical for us to see where we have a data center extended to the cloud, and then those things maybe not be close together, and then we're shuttling data across the continental US or even across the globe, not understanding how that traffic flows very well or what the implications can be. And then we start seeing things like egress costs, real slow performance, or even we go into a data center and we're missing features that are either relevant to what we want to do inside Databricks, or even how that implements into our bigger architecture with the enterprise as a whole, and then secondary features that we may need. So here's an example. We see a lot where there's a POC stood up. It may be, a data team member has access to a data center. If you're like me and you're a remote employee, you may sit on the East Coast and your company's on the West Coast. Their data center is on the West Coast, or even their consumers are on the West Coast. But I'm on East Coast, so that's sort of the option I picked, or maybe that's the one I have access to. And I set up this small POC. And at the very beginning, I really don't notice anything. We're not moving that much data. Costs are so low; they're kind of hidden. Network traffic, there's so few records, we really don't see the impact for that. But as these things happen, they tend to grow. The POC becomes a more production environment. We start getting more and more data. Maybe POC becomes dev, maybe it becomes prod, and it's not necessarily the best practice, but it's what happens. And so now we've got a problem. Another thing that can happen is you have your on-prem prod data center and an on-prem dev data center, and there may be some unusual routing where prod goes through dev or dev goes through prod, or if you're running your dev environment, is it next to your dev data center and your prod next to your prod, or are they all together? And then there's again, cost and performance issues that we see there.
There's also considerations whenever you're picking what region or that you're going to stand up your environment in. You need to look at and review what is the feature parity across the different regions you're going to utilize. A good example is your DR, your disaster recovery region. You need to make sure all the features that you are using in your primary region are also there in your DR region. The reason why we say that is we see that there are a discrepancy in release dates between regions for different circumstances in each cloud provider, and even within the products. So it's just important to make sure you are reviewing and looking at all that information before you decide what regions you're going into. Each cloud provider does populate a page in their documentation that states what is their availability for each region. So you can reference those documentations to see what may or may not be in your region that you're going into. This is an example of Azure, AWS, and GCP also have them, and also within each product line, you can find that limitations as well.
The next subsection here is just really about data regulation. So is your business subject to internal regulations or security concerns? This is an ever-growing factor that comes up, especially as there's data breaches and intrusions and privacy issues become more and more public. It's important to be aware of those regulations that you're subject to, and also be prepared to support the requirements of them up front. And so again, this avoids refactoring costs, violations, damage, and these things, the kind of top 5 sort of that we see are GDPR, CCPA, SOX, or even just supporting SOX reporting, arranging your data for that. HIPAA is a big one. And then a lot of companies are now coming up with internal rules with their security teams about how things work and access in those various aspects. And so it's a lot easier to do it up front than later, for sure. There's a 2019, which is a little bit older, but it's still at least on the order of magnitude and reflective of the cost. It states data privacies are going to cost the U.S. economy $122 billion. And a significant portion of that cost is slotted to managing data, with few companies applying that today. And in that paper, it goes on to continue and is discussing the strictness of the regulations. It says, of the companies surveyed, only 3% had met that standard. So most companies have not. A lot of this is because it's very difficult to do that when you're on legacy systems. Not all the platforms are the easiest to put those type of standards in and really support the processes for that. And so, again, doing that now is a big deal. If you're in a Databricks instance and you're moving to a Lakehouse architecture, moving that direction and moving your main consumption to that platform for data analytics gives you a pretty unique opportunity to consolidate and then implement those data regulations for data privacy and quality standards. So if you're in Databricks or you're going to Databricks, you really need to move to Unity Catalog and develop a privacy culture as soon as you can. It's really to your benefit.
When looking at data protection, bad data habits can persist. A few of those bad data habits we have witnessed over the years can consist of unnecessary copies of the same data in multiple different locations within their environments. We've seen the extremes of both where a client has denied all access to every individual that's out there, that's in their environment to the data, except for a select few, to where there's no controls at all, to where it's just wide open. If you have access to that environment, you have access to all the data assets. We have also come across clients who failed to implement primary to secondary considerations. This will be, networks, approvals, and other security concerns. There's also implications to integration processes, reporting, sending data out to vendors, and even using FTPs. So those are all things that will need to be considered. There's also proper data habits can persist as well. And some of those can be, we have seen where people store as few copies of the data as necessary. The organization has an understanding of how important roles are there. So if an employee leaves, and they know that they may not have they won't have the access anymore because their accounts are disabled, and as well as role-based access. So as people change roles within a company or promoted, they automatically will obtain the right role, access to the data, or lose access depending on what roles they may be in. Automated processes will also help transition errors and gaps from a random error to systematic error. Systematic errors are more easily found during testing and can be realized in production and are more easily corrected. Random errors are typically harder to identify and troubleshoot. There are strategies which produce systematic errors over the random errors, which would include things like ETL frameworks, CI/CD deployments, and automated testing. There's also a need to monitor. It's very important. But in reality, we all know we can't monitor all things at all times, but we should be able to monitor the critical few things and investigate the other areas whenever that is necessary. There are some strategies and techniques for applying data protection. A few of those are listed here. As you can see, there's column and table level tagging. So if you want to apply a classification within the data, we can be able to do that within Unity Catalog. You can apply dynamic views that allow you to do row level filtering and column level masking. You can also apply data elimination. We have an example of how we are able to obfuscate some data on a table, or you can do it within a view. So as you can see here, we have first name of Lindsay, and we are able to mask that into something that is not recognizable for people who may not have the ability to see the first name value. The bottom example is showing the same thing as masking, but showing you the capabilities. You can still utilize these tables that have the data masked and be able to join on them for analytical analysis or whatever the needs may need to be. However, in both scenarios, a decryption key can be kept safe for those who need to have the access to reveal what information is behind the mask.
The next section is discussing understanding cloud charges and really just developing a comprehensive billing perspective. And there's kind of three facets to this. One is that comprehensive billing perspective to fully understand Databricks and cloud billing and how the charges are incurred, gaining a consensus across your organization on billing and the billing responsibility. So it's a little bit of a political game of just making sure that everyone that's affected by the cost is kept in the loop and in alignment with the spend. And then effectively monitoring your environments for performance and cost. You know, the cloud is generally speaking a pay-to-play world, so keeping a close eye on that cost to performance relationship is pretty critical. Frequently, we see clients underestimate all the components involved in getting a cloud solution to work in production in particular. These complexities can affect the cost for that total solution. The image you see here is sort of a generic Azure diagram for all the network complexities that go into standing up a Databricks solution. So there's components that we need that, like particularly as a data engineer, we may overlook that we're not aware of or we don't work with day to day and historically haven't been responsible for managing are things like your VMs, the network components like firewalls, endpoints, subnets, NSGs, being directly involved with egress charges and then the storage accounts. And as you can see, it can get pretty complicated pretty fast. And so dealing with that stuff up front and understanding how and who is going to be responsible for those charges is pretty critical. One of our client stories is the politics that kind of go around that. And it's pretty common for an infrastructure or even like a cloud or DBA team to be responsible for the cloud charges, whether that's Azure or GCP or AWS. And that's typically due to legacy policies and responsibilities and roles. And it's not a bad fit. But this single bucket where everything that happens in the cloud now goes to that one team can cause sticker shock and then ultimately lead to unnecessary intervention when cloud analytics begin to happen and people don't understand what happens with the money. And so it's best to really resolve this ahead of time. So at one client engagement, and we've seen this multiple times, where our data engineering team is doing a good job. They understand the need for capabilities, so they go and we stand up a Databricks implementation. They look at the expenses, they look at how that cost is going to incur within Databricks, they go to their executives and they get a budget allocated and everything is good there. Then they start running and there's some secondary expenses that occur just from using Databricks in the Azure or the GCP or AWS tenant. And that infrastructure team got the bill for that, and it was an estimated $200K plus annual increase in their spend. And of course, they put a stop to projects and what's going on, where is this money coming from, who's paying for it, valid questions. In this case, they were a very professional team, and they got with the engineering team and they discussed through it and then made sure they understood the volume and the scale and how to, the new cost over, sort of relate to the old cost. And they had to go to the executive team, get an approval and an exception and get some kind of budget allocated and some boundaries around that. And then the projects continued, which was great. However, it did affect project deadlines. It put pause on the projects. You had teams sitting around kind of waiting and a little bit of concern over, are we actually going to do this thing or not? So if they had fully understood that up front, that would have been a much smoother process.
All right. So Blueprint has a product that we have developed called the Lakehouse Optimizer, or as you'll hear us refer to as LHO. LHO came about from us having multiple engagements where all the clients were saying the same questions, trying to find out the same answers. There may be multiple tools that we were utilizing or scripts that we had written to be able to help answer these questions. So Blueprint developed this product so we can be able to utilize that to help answer these common questions that we're about to go through to help clients out. As you can see on the left-hand side, we have some costs from the LHO product. What I want to highlight around this is these are costs that you may see, say, in your Azure billing. You can see your VMs, you can see your networking, you can see your disk. You also get a Databricks charge. But what this allows us to do is to say, for the given life of this job, this is our overall cost. And as you can see, Databricks is the lower amount versus the cloud cost charges that are there. Some other questions that we get is, well, great, our Databricks costs are a certain dollar amount, but what's making up that amount? And that's what we can do over here on the right-hand side, is we can help show where those costs are all coming from. So you can see how much your all-purpose compute's costing us, your Delta Live tables, SQL warehouses, serverless, etc., as well as your other cloud resources that may be there, whether it's pools, storage, etc. So you can start getting that more holistic picture of all the different areas where the charges are coming in from. Another aspect is, well, how is our cost coming across over time? It's important, and everybody knows that we need to be able to monitor what our spend is historically and currently. So we can do that as well and show the breakdown of what those costs are between the cloud provider and what Databricks is. There are some benefits of looking at this data at a month level. You can see how a new project may have affected your costs. It may have gone up. Did a reload that you're aware about have significant costs that you weren't thinking about initially? Are you experiencing unnecessary fluctuations that you didn't know? So like an example here, we have April and May. Wasn't really expecting those costs to go up, but this highlighted that our costs were going up. We were able to get that cost back under control during June. We can also utilize this data to help forecast what the budgets need to be for the next calendar year or fiscal year. The other thing that we commonly hear is, well, how do I compare my budget from last year to this year, and also derive what our commit value should be? So, again, we can utilize the data that we're collecting and be able to show you what that rolling 12-month period cost is, so you can see how we are matching up against your budget dollars, so you know if you need to increase your budgets, as well as your commit values with Databricks. Tagging is also an important strategy. As you can, tagging can be used so you can associate what those costs are for chargebacks. So if you need to be able to charge different departments or groups, or however your costing situation may be, you can be able to tag that. Or given workloads, if you want to know given jobs or domains, you can see what those costs are going to be for you at any given point in time. One of the ways that we go into clients and help them set up tags is we utilize cluster policies. That way, as you can see on the left, that's using one where we have 3 predefined tags: an environment, cost center, and project area that has a value, so we know we're going to track the workloads against that cluster. We'll have those tags. The right image is showing how we can demonstrate those charges being tied to a tag. As you can see, we are looking at a maturity level with tagging within an organization. There's a tag called business unit where we only have 3 tags being utilized, and there's a huge dollar amount that's still untagged. So you can see over time, as the values that are untagged, that value should be dropping and being tied and associated to the appropriate tag value, so you can be able to filter on those costs that way. This next graph is a viewpoint that is one of our training KPIs. We have several different types of training KPIs at a given level. This one is looking at a job run cost. As you see, the cost is all over the place. Is that expected, or are you expecting the cost to be pretty equal and even for every run and execution? Or do you expect it to be within a certain dollar range because you know the data volume fluctuates up and down just a little bit, so you know the overall cost on that job should fluctuate? You can also look at the far right of that graph and you just see that there's just no cost. You can also utilize this if you don't have a great alerting mechanism to say, hey, was this job, is it failing? Are we expecting no data to come in? What's going on here? Why are we having runs with no cost? So and there's other training KPI graphs that we have that are very useful in that monitoring space. We have a couple different scenarios that we can go over. The first scenario is an all-purpose cluster that is very small or an extra small in size, but it has a high idle time, and we leave this up and running for approximately 8 hours a day. Just say your 8-hour workday. We have another all-purpose cluster in scenario 2 that is rather large in size. It's an extra large, and it only runs 1 hour a day for a given workload and is idle, for a low amount of that time. You would come in and go, well, let's tackle the cluster in scenario 1 because it has the longest running hour, so that's got to be our highest cost. However, there are other factors at play which are used to derive the overall cost. So scenario 2 cost is actually higher than scenario 1 because of the amount of DBUs that extra large cluster is utilizing. This is a common perspective that we see and hear from clients when they're looking at cost per run or long run jobs that are out there. We need to help picture what is the overall cost, so you know what areas we need to go in to help focus on to drive down the cost the quickest way. So more jobs are a lot larger, we can help reduce those costs down, which is faster than doing several smaller items that may be identified. One of those ways is we have idolizations that you can see on an all-purpose cluster. You can see here that one cluster is 82% idle, while the other one is not idle that much. You have to take in consideration, though, and use caution whenever idle is your only consideration. This happens to be a developer cluster, and they're working through their code. So there's going to be times where they're running their code and rewriting their code or looking up a fix to their code. So there's going to be some idle time there. So you need to be cognizant of that whenever you are running through and just wanting to set the timeouts on those clusters. This is an example of recommendations that LHO has come back on a cluster. This is very common in what we see in clients on several different engagements. One of the things that I constantly hear is people always say, well, we'll just throw a bigger cluster at it. It'll cost a little bit more, but it'll run faster, and so that's got to be saving us money and time. Well, that works to a certain point. In LHO, we utilize that, and it helps show the picture and paint the picture that, a cluster, like in this case, had too much memory on the driver node. The CPU was too high on the driver node, and there was too much memory on the worker nodes. So we're using an oversized cluster, so we're not saving any time processing time because we have too much unused resources, and so therefore we're wasting money because we spun up a larger cluster than what we should have. A prime example of that is we have another scenario where a client that's a rather large client saved approximately $900,000 a year by just looking at the recommendations that the LHO was able to provide. There was also of that 900,000, 124,000 of that was just looking at job cluster recommendations alone. There can also be the extreme of where we have a smaller client where they saved 32% over a year and 57% over a 3-year period by just looking at what the recommendations were offering. And we were able to also estimate an approximate savings of $12,000 on all-purpose clusters just by applying a relatively good timeout on those clusters versus just something that it was a value that was never set. So it was just think like they didn't even have a timeout. So those are some examples of how these recommendations can help pinpoint and showcase those areas that we see waste can happen that you may not see otherwise, or we're able to help expose those pitfalls and that waste a little easier.
Some common patterns to avoid for the final section. There's many of these, but here's sort of the top handful that we see all the time. So the first one is not using parameters or widgets and just hard coding everything. It's easy, that's typically the first step. Get in there, start writing notebooks, start making jobs, figuring out how things work, and that's okay. That's typical. But getting quickly to the point where you're parameterizing those things, using them as templates so that you can reduce manual work and reuse your code really speeds up your projects. It makes things more consistent, therefore more stable. There's a huge advantage to do that, and it's fairly easy to do in Databricks. Now, the second is not fully taking advantage of the distributed processing power you get inside of Databricks. And there's kind of really two main areas where we see this that are most prominent. The first one is loading data with ADF, say in Azure or another tool like that. You can use those tools and call Databricks through like an activity that's built in, or for whatever tool that is. And a lot of times those lead to very serialized processing. Job 1, then it finishes in job 2. The typical kind of ETL flow. But Databricks has a lot of APIs. So using the workflow APIs to do those calls can allow you to sort of do those in parallel. Call, where the dependencies allow you, call the 2 or 3 or the 4 or 10 jobs all at once instead of waiting for one after the other. The second area is really writing serialized Spark instead of distributed Spark. So doing things typically in Spark or Python, where it's like maybe it's a manual loop or something like that, where all the work is being done on the driver node, not the worker nodes, not distributed out, can eat a lot of time. And just kind of getting in the practice and habits of picking the code options that do that for you better. The third is not using job or serverless clusters for production workloads. So it's pretty common for people to go in and use an all-purpose cluster for everything. It's kind of what you start with. It's very natural to do. But production workloads should really be running on a job or serverless cluster to minimize the cost. So last time that we looked through the documentation, the DBU cost is much cheaper for a job compute versus an all-purpose compute. The numbers we saw for the premium tier is 30 cents a DBU for a job and 55 cents for an all-purpose. So that's a little bit more than half the price just to go to a job. So with the same code, you can cut your costs almost in half if you're doing a lot of that. The last practice is really not using repos or an established CI/CD process. Again, a lot of what we see is growing data teams or data teams coming from legacy systems, a lot of on-prem systems where you can't really do CI/CD or repos very easily or at all, or it's just not something they're familiar with. Once you get into the cloud, the deployments are a little bit more interesting. So getting into those processes reduces the amount of manual work. It allows you to have some gating It increases the consistency in your deployments and it makes it a little bit easier to facilitate some automated testing, and it kind of just has a better cadence with some of your support staff, like the DBAs and admins and various things. I believe that is the end of our presentation. Susie, do we have any questions that we can take or answer?
Susie,
It would help if I keep off mute. A reminder for those who are attending, go ahead and add questions that you have in the comments. We do have one. So this says, if you previously ran a job in an all-purpose cluster, but later switched to a job cluster, is there a way to track the cost difference for running the job in both scenarios to validate optimization?
That's a great question. The answer, if it's the same job workflow, the answer is yes. So one of the features that we also do within the LHO product, we track any configurations to the clusters over time. So you can be able, and you in that same run cost KPI graph that we were showing earlier, you'll be able to pinpoint both those graphs together, so you can see when you change the cluster configurations to what the costs are now for that given run. So you can be able to look at both scenarios all at one time, so you can see the cost savings or cost increase that you may have had.
Awesome. Thanks, Christian. And for those who are joining, again, if you have questions that come up later, you can also email us. For those who registered, you'll get a link to this recording, and you can also reply to that so that we can connect you guys back. Thank you once again, Nick and Christian, for an excellent session. We really appreciate it. And to everyone joining today, don't forget to mark your calendars for our next webinar, which is November 6th, integrating web applications with Databricks serverless compute, featuring our other Databricks champion, Shannon Lauder. You can sign up on our website or on our LinkedIn page. Thanks again, you guys. Have a great day. We'll see you next time.
Thank you.
Thank you.